Executive Information Engineers in Andhra Pradesh Information Services, Electronics and Communication Engineering, 2019 Question Paper Solutions Part 3, that is from question number 61 to question number 90. First question, the relationship between autocorrelation function and power spectral density. We know that autocorrelation function and power spectral density form a Fourier transform pair, that is S xx of omega is equal to integral minus infinity to infinity r xx of tau e power minus j omega tau d tau, where r xx of tau is autocorrelation function and S xx of omega is power spectral density. Similarly, the inverse Fourier transform to find autocorrelation function is r xx of tau is equal to 1 by 2 pi integral minus infinity to infinity S xx of omega e power j omega tau d omega. Correct answer is option 1. The Fourier transform of autocorrelation function is equal to power spectral density. 62nd question. Ideally, a DC load line is a straight line drawn on the collector characteristic curve between. So this DC load line is a straight line drawn on the collector characteristic curve between cutoff point, that is VCE cutoff, and saturation point ICE saturation. This DC load line is also called static load line. The other name of this DC load line is static load line. Correct answer is option 2. It is drawn between VCE cutoff and IC saturation. Next question. The access time of ROM using bipolar transistor is about. So we know that access time is the time taken to read a stored word after applying the address bit. For bipolar memories have faster access time than mass memories. These bipolar memories have faster access time than metal oxide semiconductor memories. The access time of ROM is 1 microsecond. Correct answer is option 1. Question number 64. The compensator which adds negative phase to the system over a specified frequency range is called. So that is lag compensator. Lag compensator adds negative phase to the system over a specific frequency range. Similarly, lead compensator adds positive phase to the system over a specific frequency range. So here lag and lead compensator circuit diagrams are mentioned. In lead compensator, pole is 0 is dominant over the pole. Pole is far away from the origin and 0 is near to the origin. Whereas in lag compensator, pole is dominant over 0. So this lag compensator is used to improve the steady state response, whereas lead compensator is used to improve the transient response. Here correct answer is option 3. Question number 65. A 4-bit ring counter is in turn clocked by a 10 MHz clock signal. The frequency and duty cycle of the output flip-flop are dash and dash respectively. So we know that output frequency F0 is input frequency by number of states. Here n bit ring counter is given. For n bit ring counter there are n used states. For 4-bit ring counter total number of states are 4 and the given input clock frequency is 10 MHz. Now the output frequency F0 is input frequency 10 MHz divided by number of states, that is 4. So 2.5 MHz. Output frequency is 2.5 MHz. Duty cycle is, it's a ratio of on time duration to total time duration. Duty cycle of each flip-flop in ring counter is 1 by n into 100%, that is n is the number of states, 1 by 4 into 100. Duty cycle is 25%. So the correct answer is option 2, 2.5 megahertz output frequency, and 25% is a duty cycle of ring counter. Question number 66. In amplitude modulation, spectral overlap is said to occur if lower sideband for positive frequencies overlap with its image frequency for negative frequencies. What condition must the modulated wave satisfy if you are to avoid the spectral overlap? Here message signal bandwidth given is W. To avoid the spectral overlapping between lower sideband of positive frequencies and the upper sideband of negative frequencies, the carrier frequency should be greater than message signal frequency. Correct answer is option 4. Here is a message signal with the frequency from omega m to minus plus omega m to minus omega m. Carrier frequency is from omega c to minus omega c, and amplitude modulated signal, for amplitude modulated signal, the spectrum upper band highest frequency component in USB is Fc plus B and lowest frequency component is Fc minus B. Correct answer is option 4. Carrier frequency should be greater than message signal bandwidth. Question number 67. In graded index fiber, refractive index dash inside the core. In graded index fiber, refractive index is maximum at the center of fiber axis and decreases gradually as moved away from core and reaches to minimum at core cladding interface. So here refractive index profile is maximum at core axis and gradually decreases, and it is minimum at core clad interface. Whereas in case of step index fiber, refractive index of core is uniform. Correct answer is option 3. For graded index fiber, refractive index decreases gradually inside the core. Next question. A transmission line is distortionless if. Correct answer is Lg is equal to Rc. For a distortionless line, attenuation constant alpha is independent of frequency, phase constant beta linearly dependent on frequency. The condition for distortionless transmission is R by L is equal to G by C, that is Lg is equal to Rc. A line is said to be distortionless if output is an exact replica of input. Question number 69. The directivity of antenna is dash the value of its directive gain. So directivity of antenna is maximum value of directive gain. So that we know maximum directive gain is called directivity. Directivity cannot be less than 1 and it lies between 1 to infinity, whereas directive gain may lie between 0 to infinity. For lossless isotropic antenna, directive gain and directivity is same. Correct answer option 3. Question number 70. The light emitting diode is the LED light is emitted because of. In light emitting diode, radiative recombinations of electrons and holes emits energy in the form of light, whereas non-radiative recombinations of electrons and holes emits energy in the form of heat. So recombination of charge carrier takes place. Because of recombinations of charge carriers, light gets emitted from LED. Those recombinations are radiative type recombinations. For non-radiative type recombinations, heat is released. Next question. The ideal maximum peak output voltage and current for the circuit shown below is. Here the transistor T1 is on. Here the transistor T1 is on and the given load resistor RL is 16 ohms. Once T1 is on, when this transistor is on, the bias voltage, supply voltage 20 volts get appear at the output. So V0 is 20 volts, maximum output voltage is 20 volts, maximum peak load current is V0 by RL, that is 20 by 16, 1.25 ampere. Correct answer is option 3, 20 volts and 1.25 ampere. Question number 72. The reverse leakage current of the transistor when connected in common base configuration is 0.2 microampere and it is 20 microampere when the same transistor is connected in common collector configuration. The large signal DC current gain of transistor in CE configuration is dash. Here reverse leakage current in common base configuration ICBO. Given ICBO is 0.2 microampere and the reverse leakage current in common emitter configuration is 20 microampere. We know the relation between reverse leakage current in common emitter configuration and reverse leakage current in common base configuration in terms of beta is ICEO is equal to 1 plus beta ICBO. Given ICEO is 20 microampere is equal to 1 plus beta into 0.2 microamperes. 1 plus beta is 100, beta is 100 minus 1, the value of beta is 99. Correct answer is option 1. Next question, to minimize the granular noise, the step size must be small. In delta modulation, to minimize slope overload distortion, step size should be large, whereas to minimize the granular noise, step size should be small. Correct answer is option 2. Granular noise, when the step size is too large compared to small variation in the input signal, that is for a constant input, then output of delta modulator will be the sequence of alternative positive and negative pulses. Question number 74. A 10-bit digital to analog converter given to a maximum output of 10.23 volts, the resolution is. So given 10-bit digital to analog converter, that is n is equal to 10. Output voltage of digital to analog converter is 10.23 volts. We need to calculate resolution. Resolution R is output voltage by 2 power n minus 1, 10.23 divided by 2 power 10 minus 1, that is 10.23 divided by 1023. Its value is 0.01, that is 10 millivolts. Correct answer is option 3. Next question, an inverting amplifier has closed loop gain of 25. The op amp has an open loop gain of 10 power 5. If another op amp with an open loop gain of 2 into 10 power 5 is substituted in the configuration, the closed loop gain will be. So closed loop gain remains same because the closed loop gain of inverting operational amplifier is given as minus Rf by Ri, where Rf is feedback resistance and Ri is the input resistance. Closed loop gain of inverting amplifier is independent of open loop gain. Therefore, even if open loop gain gets doubled or tripled, the closed loop gain remains same. Correct answer is option 2. Question number 76. Identify the drawbacks of radar. So, option 1, it can detect and track the moving objects. So it is not a drawback. It has very narrow coverage. So option 2 is correct. It is a disadvantage. So that is drawback. It has very narrow coverage. Option 3, it is able to operate day and night. It's an advantage. Option 4, It can able to operate in all weathers. The advantages are option 1, option 2, option 1, 3 and 4. 1, 3, 4 are advantages of radar, whereas option 2 is a question number 77. The system is represented by a difference equation y double dash plus 5y dash plus 6y is equal to u. The state vector matrices A, B, C, D are. Given difference equation is y double dash plus 5y dash plus 6y is equal to u. It can be written as d square y by dt square plus 5 dy by dt plus 6y is equal to u of t. Let y1 dash is equal to y2 is dy by dt. D square y by dt square is equal to y1 double dash y2 dash is equal to y3. So rearrange the expression in this form. Then we will have system matrix A is y1 dash y2 dash as a column matrix. We will get 0 1 minus 6 minus 5, and input matrix B is 0 comma 1. Output matrix C is 1 comma 0, and transmission matrix D is 0. Correct answer is option 1. Question number 78. A silicon sample is doped with 10 power 7 arsenic atoms per centimeter cube. The equilibrium hole concentration at 300 Kelvin is dash. Given intrinsic concentration is 1.5 into 10 power 10 per centimeter cube. Here intrinsic concentration is Ni, donor ion concentration Nd approximately equal to electron concentration, that is N is 10 power 7 atoms per centimeter cube, and hole concentration is P. From mass action law, P is equal to Ni square by N, that is Ni square by Nd. So Ni square is 1.5 into 10 power 10 whole square divided by Nd 10 power 17. We will get whole concentration is 2.25 into 10 power 3 per centimeter cube. So correct answer is option 2. Question number 79. The DC gain of system represented by the transfer function 5 by s plus 2 s plus 3 is. So given open loop transfer function g of s is 5 by s plus 2 into s plus 3. DC gain is limit s tends to 0 s into g of s, that is limit s tends to 0 g of s is 5 by s plus 2 into s plus 3. Put s is equal to 0, we will get 5 divided by 2 into 3, 5 by 6. DC gain is 5 by 6. Correct answer option 2. Question number 80. An air-filled rectangular waveguide has inner dimensions of 3 centimeters and 2 centimeters. The wave impedance of TE20 mode of propagation in a waveguide at a frequency of 30 gigahertz is. In the question they have given air-filled waveguide of dimension A by B, that is 3 centimeters by 2 centimeters. Now the propagating mode is TE20 and the operating frequency is 30 gigahertz. Free space intrinsic impedance is 120 pi or 377 ohms. The cutoff frequency Fc is equal to C by 2 pi square root of m pi by a whole square plus n pi by b whole square. Here give m value is 2 and n value is 0. From this cutoff frequency is C by 2 pi square root of 2 pi by a is 3 centimeter, 2 pi by a whole square. On substitution we will get cutoff frequency is 10 gigahertz. Now TE mode wave impedance. For TE mode wave impedance is eta naught by square root of 1 minus fc by f whole square, where eta naught is 120 pi, that is 377, divided by under root of 1 minus 10 gigahertz by 30 gigahertz whole square. 377 divided by under root of 1 minus 1 by 3 whole square. Its value is 399.86 ohms intrinsic impedance for a TE mode. So correct answer is option 4. 399.86, it is approximately equal to 400 ohms. Correct answer is option 3. Question number 81. Which statement is wrong for ideal characteristic of operational amplifier? For an ideal op amp, slew rate is infinity, input impedance is infinity, output impedance 0, bandwidth, power supply rejection ratio, common mode rejection ratio are infinity, open loop gain is infinity, offset voltage 0, input bias current 0. So from this, wrong statement is slew rate should be infinity, but here they have given slew rate is 0. Correct answer is option 1. Question number 82. A transfer function has two zeros at infinity. Then the relation between the numerator degree m and denominator degree n of the transfer function is, given numerator degree is m and denominator degree is n. Given the transfer function, also given the transfer function has two zeros at infinity. Two zeros at infinity is nothing but a two poles. Degree of denominator n is degree of numerator plus 2. N is equal to m plus 2. M is n minus 2. Correct answer is option 1. Question number 83. The magnetic field strength of 5 microampere per meter is required at a point on theta is equal to pi by 2, 2 km from the antenna in an air. Neglecting ohmic losses, how much power loss, how much power must the antenna transmit if it is a half wave dipole? Given magnetic field strength is 5 microampere per meter and free space intrinsic impedance is 377. In far field, power density S is, in far field power density S is equal to 1 by 2 eta naught h square. Eta naught is 120 pi, that is 377. H is 5 microampere per meter whole square. On substitution, we will get S is equal to 4.712 into 10 power minus 19 watt per meter square. Now the total power radiated S is equal to total power transmitted PT into D half wave dipole directivity divided by 4 pi r square. Now transmitted power is S into 4 pi r square by D. So D is 1.64 for half wave dipole and given radius is 2 kilometers, that is 2000 meters. On calculation, we will get total power PT is 144 milliwatt. Correct answer is option 4. Question number 84. A Hertzian dipole of length 2 meter operated 1 megahertz if copper conductor has conductivity 57 megasiemen per meter and relative permeability mu r is 1, radius A is 1 millimeter, then the radiation efficiency is, we know that for Hertzian dipole radiation resistance Rr is 80 pi square L by lambda whole square. Here length L is 2 meters and wavelength lambda is C by F. C is 3 into 10 power 8 meters per second and frequency F is 1 megahertz. So from this lambda value is 300 meter. Substitute those values, we will get radiation resistance 0.0351. Then surface resistance, then we need to calculate surface resistance to get the loss resistance. Surface resistance formula RS is under root pi f mu by sigma c, where mu can be replaced as mu naught mu r. Mu naught is 4 pi into 10 power minus 7, frequency is 10 power 6, conductivity sigma c is 57 into 10 power 6. From this, surface resistance is 2.63 10 power minus 4, and loss resistance RL is equal to L by 2 pi a. L is length, 2 pi a is radius into RS, surface resistance. From this, loss resistance is 0.0838. Using this loss resistance and radiation resistance, we can calculate the efficiency. So radiation efficiency is radiation resistance to total resistance, where total resistance is sum of radiation resistance plus loss resistance, that is 0.0351 divided by 0.0351 plus 0.0838. Here efficiency is 32.04%. Correct answer is option 1. Nearest answer to 32% is 29.4%. Question number 85. A regulator has no load output voltage of 10 volts and full load output voltage of 9.9 volts. The percentage load regulation is the variation of DC output voltage as a function of DC load current is called regulation. Percentage regulation is given as V no load minus V full load by V full load into 100. That is, given no load voltage 10 volts and full load voltage 9.9 volts. Percentage regulation is 10 minus 9.9 divided by full load voltage 9.9 into 100. It is 1.01%. Regulation is 1.01%. Question number 86. The modulation scheme commonly used for transmission from GSM mobile terminal. GSM stands for Global System for Mobile Communication is. So the modulation scheme we are using in GSM is GMSK. Gaussian minimum shift keying is a modulation scheme used for transmission of signal in GSM. Question number 87. The divergence of vector field A at point P is defined as. The divergence of vector field A at point P is given as divergence of A is equal to del dot A is limit delta V tends to 0 closed surface integral of A bar dot ds bar by delta V. This is divergence. Similarly, the curl of a vector field at a point P is given as curl of A is equal to del cross A, that is limit s tends to 0 closed line integral of A bar dot dl bar by delta S. This is the equation for curl. In the question they have asked divergence. So correct answer is option 3. Limit delta V tends to 0 closed surface integral of A bar dot ds bar by delta V. Question number 88. In 8085 microprocessor, the shift register which store the result of an addition and overflow bits are respectively. Correct answer is E and F. Accumulator register and flag register stores the result of addition and overflow flag. Accumulator is an 8-bit programmable register where the result is stored after arithmetic and logical operations with some exceptions. All arithmetic and logical operations performed with the contents of accumulator and the results are stored in the accumulator itself. Whereas flag register is an 8-bit register in which 5 of the bits carry significant information in the form of flags, that is sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. Correct answer is A and F. Next question. A open circuited coil has. So open circuit implies resistance is infinity. For a coil, quality factor Q is equal to omega L by R. If resistance is infinity, quality factor is 0. If quality factor is 0, implies inductance L is also 0. So that is a open circuit coil has infinite resistance and 0 inductance. Question number 90. In control system, when maximum value is subtracted from step value and the result is divided by the step value, the result is called as percentage overshoot. Per peak overshoot is maximum positive deviation of output with respect to its desired steady state value is known as maximum peak overshoot or peak overshoot. That is, peak percent overshoot is given as C of Tp minus C of infinity by C of infinity into 100. This maximum overshoot or peak overshoot is a normalized difference between time response peak to steady state value. C of infinity represents steady state value, C of Tp represents time response peak value. So correct answer is option 3.